Let's draw the Lewis structure of BF3, which is boron trifluoride. To accurately draw the Lewis structure of BF3, follow these steps. Begin with a rough sketch. Illustrate the chemical bonds between the atoms. Identify and mark lone pairs on the atoms. Ensure each atom follows the octet rule as closely as possible. Wrap up by considering the formal charges, aiming for a stable Lewis structure with the least formal charges possible. Before drawing the initial rough diagram, begin by calculating the total number of valence electrons and then identify the central atom. The total valence electrons in BF3 are determined by summing the valence electrons of each atom. Boron, a member of group 13, provides 3 valence electrons, while each fluorine, a group 17 element, contributes 7 valence electrons. With 1 boron and 3 fluorine atoms in BF3, the total valence electrons calculation is 3 for boron plus 7 for fluorine multiplied by 3, resulting in a total of 3 plus 21 equals 24 valence electrons for BF3. When determining the central atom for BF3, select and position the element with the lower electronegativity at the center. With electronegativity values of 2.04 for boron and 3.98 for fluorine, favor boron due to its lower value. Therefore, for the preliminary sketch of BF3, position boron at the center and arrange 3 fluorine atoms on the outside. 2 electrons represent a single chemical bond. Therefore, we will first position 2 electrons on the left side to indicate the chemical bond between boron and the left fluorine. Similarly, we will place another 2 electrons on the right side to represent another chemical bond between boron and the right fluorine. Finally, use 2 more electrons to show 1 more chemical bond between boron and the bottom fluorine. In this way, out of the 24 total valence electrons, we have used 6, leaving us with 18 electrons still remaining. Lone pairs consist of electron pairs not used in chemical bonding. Remember, each pair comprises 2 electrons. With 18 electrons remaining, we can form 9 electron pairs and mark them on the structure as lone pairs. It's important to note that both boron and fluorine, being period 2 elements, cannot hold more than 8 electrons in their valence shells. Another key point to remember is to always start marking lone pairs first on the outside atoms and then on the central atom. In BF3, each of the 3 outside fluorine atoms receives 3 lone pairs, while the central boron atom doesn't get any lone pair because we only have 9 lone pairs to mark on the structure. You can observe that the octet is complete on the 3 fluorine atoms, but not on the central atom boron. It's important to note that boron has an exception. It does not require 8 electrons to complete the octet. So, there's no need to worry about the octet rule. Let's now check the stability of the structure by calculating the formal charges. This is the formula we can use to calculate formal charges for the BF3 Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Just input the data and insert the values to determine the formal charges for each specific atom. For boron atom, valence electrons are 3, non-bonding electrons are 0, and bonding electrons are 6. So the formal charge will be equal to 3 minus 0 minus half times 6, which equals to 0. For each fluorine atom, valence electrons are 7, non-bonding electrons are 6, and bonding electrons are 2. So the formal charge will be equal to 7 minus 6 minus half times 2, which equals to again 0. The formal charges of both boron and fluorine atoms are 0. Therefore, this structure is the preferable stable Lewis structure of BF3. To represent a pair of bonding valence electrons, we can simply draw one horizontal line. Since there is one pair of electrons between boron and each fluorine atom, draw one horizontal line between boron and each fluorine atom, indicating that boron is single bonded with 3 fluorine atoms. So, that wraps up the Lewis structure for BF3. If this breakdown made sense, feel free to hit the like button, share the video, and subscribe to the channel.